I'm still your teacher Osbert Nwarinda. I will welcome you to yet another episode where we are looking at the link reaction. Remember, we said that pyruvate as one of the products of glycolysis, which crossed from the cytoplasm where it was produced from, and it came into the matrix of the mitochondria, does not straight away join the Krebs cycle. We are saying that the pyruvate must undergo some modification. Of course, you might be there asking but teacher, you are saying that the pyruvate cannot join the Krebs cycle. Why? What is wrong with it that cannot join the Krebs cycle? So it means, if I can think about it, we can think that the pyruvate with its 3 carbons may be the enzymes which catalyze reactions within the enzyme which catalyze reactions within the Krebs cycle may not be able to process or may not be able to catalyze reactions where pyruvate is part. Remember, enzymes are usually specific in what? Enzymes are usually specific in action. So it means maybe the enzymes which catalyze reactions within the Krebs cycle may not be able to catalyze reactions where we have pyruvate the way it is physically, the way it is pyruvate without it undergoing any modification. So in the link reaction here, we want to see the different modifications that are performed onto this pyruvate to make it suitable for the enzymes maybe which are found within the Krebs cycle to be able to deal with it very well. I understood? Hope now I've answered that person who was saying, teacher, you tell us why pyruvate cannot come straight. Yes, pyruvate may not come straight because of that reason. So what happens to this pyruvate? What are the modifications that happen to this pyruvate so it can be fit to enter into the Krebs cycle? We are saying, one, we're having our pyruvate here. We're having our pyruvate here. Now, this pyruvate is 3 carbon. Now, we are saying this 3 carbon pyruvate is going to be first turned into something which is having less carbons. And this something that is going to be having less carbons, for us to have carbon atoms reduced from 3 to, for example, 2, then what happens? I already told you previously that whenever we have carbons, when they are reducing, for example, previously when we were looking at the fate of pyruvate, we saw that pyruvate was turning into ethanol. And the process of pyruvate turning into ethanol, pyruvate was 3 carbon, ethanol was having 2 carbon. We had decarboxylation, we had loss of a carbon in the form of carbon dioxide. So that's what also happens here first. So actually, stepwise, this is what occurs first. So the first thing that happens to this pyruvate is that this pyruvate first loses a carbon in form of carbon dioxide. So it first undergoes, decarboxylation. First undergoes decarboxylation. So after losing the carbon in form of carbon dioxide, then another thing that occurs to this thing here is what we are calling dehydrogenation. And we have been having we are saying the next thing that occurs to this pyruvate is what we are calling dehydrogenation. In other words, we have loss of or removal of hydrogen. So during this reaction, as this pyruvate is turning into whatever we are going to form here, there is loss of hydrogen. And we have been having a molecule. We had a molecule under glycolysis which enabled us to remove hydrogen from pyruvate, from pigal through a series of reactions to form pyruvate. Do you still remember that molecule which we saw in glycolysis, which enabled that was important in converting pigal into into pyruvate that enabled, within which it enabled the removal of hydrogen. Yeah, that molecule was called what? It was called NAD. It was NAD plus. So we also have the same NAD here. So this NAD will also come help us to remove hydrogen, and in that way we shall have our NAD plus helping us remove hydrogen. And I already explained this NAD plus within glycolysis. So if you, in case whatever I'm going to write here about NAD, if they confuse you, you go and again rewatch the video I made about glycolysis. There is something I tried to explain there very well. So we saw that this NAD, once it comes and removes the hydrogen ions, it removes hydrogen ions, removes electrons, and so on. And in the process of removing hydrogen ions and electrons in this reaction here, it becomes NAD H plus like that. That's what we usually get. Though some people may just prefer writing NAD H, and they stop it at that. Anyway, if you write NAD H, that's the main product. You can, it is also okay, but we are saying the proper way. You say NAD H plus H ions or plus hydrogen ions or plus protons. Now we are saying once these two have occurred in that order, once these two processes have occurred in that order, now chemically, if you go into the biochemistry, the product we form here, if you go into the biochemistry of this thing, the product we form here is a product we form an acetyl group. An acetyl group, and we will go to acetic acid. Acetic acid, for example, how many carbons is it having? It is having 2 carbons. Like the way we see ethanol, and so on. So this acetyl group, of course, automatically will be having 2 carbons. But because this acetyl group, which is just the we may not have a molecule that is there, which is called acetyl group for some time. Why? Because you see, such kind of molecules are usually reactive. So once it is formed, once this acetyl group is formed, of course, what is first formed, but once it's formed, now this acetyl group or this acetyl molecule or this acetyl group is immediately combined with a molecule which we are calling, it's combined with a molecule, and that molecule is what we are calling what? We call it coenzyme A. We call it coenzyme A. Yeah, that's how we can shorten it as coenzyme A. And once the two have combined, then we shall form a product here. We shall be forming a product here which is called acetyl, coenzyme A. Now, this acetyl coenzyme A, of course, it also has 2 carbons. Now, this acetyl coenzyme A is the molecule that is now fit. This is the molecule that is now fit to come and enter into the Krebs what? Into the Krebs cycle. Into the Krebs cycle here. So this acetyl coenzyme A is the one which will now be fit to come and enter into this Krebs cycle so that we can have it progress. That means as one of the conditions for entering the Krebs cycle, one, this one must first be turned from 3 carbons into 2 carbons. And then we are saying even after it has been done into 2 carbons, acetyl group just the way it is alone, it still also may not be able to be catalyzed by the reactions which are found where? Into the matrix. Remember, at some point we say the matrix has got very many enzymes. The matrix of mitochondria, in one of those first videos, we say it has got very many enzymes. And so those enzymes usually catalyze very many reactions which take place there. So we are saying these reactions which take place here may not be able to catalyze a reaction where we just have acetyl group just the way it is plainly. And therefore, that's why this acetyl group must be first combined with a molecule which we are calling coenzyme A. Now, if you go to chemicals of life, coenzymes are what? Coenzymes, these are organic molecules. These are organic molecules that usually help enzymes to do or to speed up the rate of chemical reactions. These coenzymes usually here, you can hear the word even co-enzymes. Co is like a helper, like a colleague. So coenzymes, these are organic molecules that usually that assist enzymes to catalyze the reactions faster. And of course, these coenzymes do this work in different ways, which I may not go into details within this episode. So we are saying it means when you form the acetyl coenzyme, when you form this acetyl group, we are saying the way it is alone may not still be able to come and deal, and it becomes dealt. It becomes dealt by the enzymes which are found within the Krebs cycle. So what happens? We are saying this acetyl group must again combine with some molecule, and that molecule are calling it coenzyme A, so that it can be put in a way that it can easily be worked upon or be catalyzed for reactions within the Krebs cycle. So this is something we are calling the ring reaction. However, so it means if I have my molecule, for example, as glucose, assume the food I have eaten that is going to help me produce energy is glucose. That glucose is going to be broken down via glycolysis to form pyruvate. And then after forming pyruvate, we are saying this pyruvate will now, in presence of oxygen, the pyruvate will come into the matrix of mitochondria. Then this pyruvate will now undergo this reaction and to form acetyl coenzyme A. And then with acetyl coenzyme A, I can now be able to come into the Krebs cycle. And then within this Krebs cycle, I will produce very many ATP, and there will also be very many other molecules that I will produce here, as we are going to see. However, at a given point, for now, this link reaction, I'm leaving it at this, but I want to tell you that as we progress, I will have to bring this link reaction and add in some other things. For example, maybe this one I can add it from here. Let me first add this one from here. Why don't you come in my next episode and we watch that one together there? Thank you very much.